Hi everyone, I'm Melanie, one of the applications engineer of Computrends, and thank you for visiting this session which is about SolidWorks CAD desktop presentation. This session is about SolidWorks CAD, a desktop demonstration of a miter saw design. This is our miter saw design, and a miter saw is a specialized tool that lets you make cuts at a variety of angles. The saw, this one, has a blade mounted on a swing arm that pivots left or right to produce angled cuts. You can use a miter saw to quickly make cuts for crown molding, picture frames, door frames, window castings, and more. Now, this session is intended to serve as a standard introduction to SolidWorks. It includes part, assembly, and drawing creation, which highlights the ease of use of SolidWorks and the features like Instant 3D, Nim Expert, change propagation, collision detection, and design validation. Okay, so let's get started by creating a new yoke part. So using a template for part. Here we are showing you the ease of use of SolidWorks. Okay, so let's create by choosing a sketch, a plane, and using the shortcut toolbar to make the system easy to use. Okay, so let's create a circle and creating center line. So here you can see the blue geometry, which means the sketch is not yet fully defined, or what we call underdefined. So adding relation, making the two circles equal relation. So adding dimension. Okay. So you will notice now that the sketch is now in black, which means it is fully defined. So adding dimension, double clicking will take you out of the sketch, and using the instant 3D capability, you can easily pull the arrow to achieve the thickness. Now, using the context bar, it's easy to use the shortcut toolbar to select the vertices. You can create or add a new geometry and add some circle, and dragging the vertex, you can see how your sketch behaves. Let's use the fully defined sketch tool. So see, it will automatically create those values, but we want to modify them based on our preference. Okay. Now, it's fully defined. Exit the sketch. Okay. Let's use the contour select tool. Using the contour select tool, it's very easy to just select which sketch you want to add features by dragging the arrow using the Instant 3D. Okay, so creating a boss by pulling it out. If you want to cut it, just choose those faces. But in this case, we want to convert it to cut instead of extrude boss. Now, we want to copy this body to the other side. So using the right plane, we can use the mirror command and select the body. Now, the next thing we want to do is add some fillet. Using again the shortcut toolbar, using the Fillet Expert, just simply select the back edge and the other side and change it to select the bottom edge. You can see the selection manager. Okay. So it's very easy to select the edges you want to apply the fillet. What if you want to make some changes into this part by just dragging that part? You can see that you can easily change the radius of the fillet. And everything is happening real time. Okay. Okay. So let's change these two fillet. And again, using the Fillet Expert, you can easily change and resize to 10. Next, we want to add some material. Okay, just picking the edit material. Select the material you want to apply. So you see the physical properties of the material you choose and by accepting it and save it. This is very useful when you want to validate your design. Our next step is to get our new yoke into the assembly by opening the assembly and insert our new yoke to the assembly by simply dragging it to the position. So there's no need to rotate. Okay. By using the Smart Mate, drag the cylindrical face to the rod and do the same to the other side of the rod. Okay. And then again, assemble this part by using Smart Mate and selecting the whole of the yoke. So we were able to add all the necessary mates to our assembly. Now that we have our yoke assembly, you will notice that the link is hanging in space. So we need to add a feature to the yoke that allows us to mount the link. So to do this, edit this part. Okay, locate the feature of the part to another part. So edit this part to the context and add a boss to this part. Sketching on the side piece of the yoke, convert the edge of the washer. Okay, draw a straight line. Okay. Okay, double clicking will take exit as and use the contour selection again. Let's extrude using the two contours. Now we have created the boss. Notice that at the opposite side, we don't have a hole for our shoulder screw. So let's use the hole wizard feature. Access the hole wizard from the shortcut bar. Let's show out the capabilities of the hole wizard using the different hole type. Here, let's use the tapped hole and select the position. Okay. You can see that the hole wizard is great job for doing this. Now, here's the good time to test our assembly, how it actually functions. So let's move the assembly up and down, but notice that down there at the yoke, there seems to be an interference. So to do that, let's access the Move Component tool. Let's use the collision detection and select the yoke only. Now, move again. So you will notice that there is a highlighted part between the head and this side of the yoke, which means that there is a collision. So to solve that, let's fix and change the 60 millimeters to 45 millimeters. So there's a change on the width. But not only that, we need to check all the other holes and other relations of the part. Now let's check again. Move up and down again with the assembly. Okay. So now it's showing the appropriate motion that we want to achieve. Now that we have concluded our assembly, let's go back to the yoke part that we have created. Notice that all the changes that we have made appears and shows here. So you can rotate, so you can check everything, you can inspect all the changes that happened. Okay, now let's see this capability using a control. You can easily copy the fillet to the other edge of the yoke. The next part of the demo is DimXpert. It is very important to set this up before adding 3D dimensions to all your parts. And take note that part orientation is very important. Make sure that your part is oriented as shown. Let's go ahead and jump into DimXpert. So select your primary, secondary, and tertiary setting and right-click and choose OK. SolidWorks add all the dimensions to our part. Now you can change the position so it is more orderly. You can move the dimension up so it looks better. And position the other dimension around. Okay. Notice the 100 millimeters, but we want to manage or control the distance between the two inside cylindrical bosses. Okay, so let's take a look whether all our part dimensions are fully constrained. So you can see that everything is in green, which means go. In this case, our part is fully constrained. But if we delete one of the dimensions, you will notice that one of the faces is not green. Now, let's add our own dimension by adding our own dimension using the DimXpert location dimension. Okay. Selecting the inside faces. And now we have our annotation fully constrained, but let's turn it off. Turn off everything. Okay. Now let's go ahead and create our drawing using our template. Make sure that you click the import annotation, DimXpert annotation, and the auto start projected view. So we have the available views already. Drag the front view and the right view and then the isometric view at the top. So you can see that the SolidWorks create a really nice job to add all those dimensions in our 2D drawing. But if you notice, we have multiple bosses inside our part, so it creates multiple dimension. So we can delete the other dimension to avoid duplicate dimensions. So make it more orderly, clean up the 2D drawing by arranging the dimensions. Now we want to communicate this information to our manufacturing department. So let's use the e-drawing. Okay. So this e-drawing is very fantastic tool also to allow the other users to see and view the dimensions, rotate the part, so they could understand your own model. You can also add markup. So let's add markup to this model. So when we send it to someone else, we can let them know what you want them to do. So here we add that it's too heavy, showing us 0.73 kilogram. So there are two tasks that we want to do. Make it lighter, and then make sure that the factor of safety is greater than 3. Okay, so let's close 2D drawing. Now, in order for us to lighten our part, we have to go to our assembly environment and do assembly analysis. But we already done a previous analysis. So let's open the PDF file for the previous analysis and let's get some information that we can use for our new study. Looking at all this information, we can get an idea what load we have to use for our new study. So with those information, let's begin our new analysis. So let's remove or hide the other component and just focus on this assembly with these two rods. Okay. Let's create a new study and just static study. So we have to understand we are making a study on an assembly. So let's define the load. First, we have to add the force. We add pressure, a force. Let's select the head, the direction, and add, let's say, 750 newtons. Add another force. Should be on the opposite side. Again, select the direction and add the load. Okay. For now, let's hide all those information and then let's run our analysis. So now it's processing the analysis. So let's wait for the results. Now the result appeared. So it shows the result for the stress. Okay, and then we also have a displacement analysis. So we can determine the accuracy of the cut. You see, it shows the, but in this case, we are interested on the factor of safety. So, because we have a multiple materials, we need to focus on our new yoke. Create a new plot and get a new report for this yoke part only. But our requirement is 3, so it's really below our requirement. So we need to redesign our assembly or our part. So it gives us clue where or which part we need to adjust or modify. Now let's go back to the part environment to make these changes. We want to remove some materials from the mounting area around here. So let's access the design library and we can see that we can add some features that we can use by just drag and drop this feature to our model. Locate the edge and accept it. And the good thing about it is it consists of many features like fillets, rib, and extrude. Now that is very easy to drag and drop that features. But we want to mirror that to the other side. Okay, remove the material around there. So let's reuse a part, which is the end cap, by using the search. And reuse a particular part, like the CAD packet, and add this to our design. And you can see that everything is fully editable in our side. You just add some dimension or change some dimension and exit the sketch. So let's add some more fillet to this edge. You just key in 1 as our radius and use other options, and that it could automatically select all the edges that we need to apply those new fillets. So we were able to lighten and we're removing some part of the materials. And now let's go back to our assembly and continue with our analysis. Now you can see all the changes that we've made in our part environment, and we run our analysis. In a few seconds, you can see the result. Let's check our factor of safety. This time it reports a 2.6, it's still below our requirement, which is 3. So let's add more material and check which part of our assembly needs additional material. Okay. So to strengthen our part, let's add material to this yoke. Change the dimension and even the fillet, add from 10 to 15. Let's update our geometry, hold on our part and assembly. Okay, run again the analysis. Okay, again, a new result appear. Let's check again our factor of safety, which is now 3.2, which is within our design criteria. Now, it's a good time to show our trend tracker. So you can see how the changes we've made with our design. And it shows the various iterations we made. The trend tracker is a fantastic tool to show all the iterations we've made with our design. Okay, let's add all the other parts. Let's get them back all together, all the components together. Okay. Now we've made quite a few changes in our yoke part, and going back to its drawing, you will notice that the drawing is fully up to date. You can see all the added features we made to lighten our part, and we want to create a detail of those features. Let's add drawing information by creating a section view. Okay. Create a line to create the section view. Let's add a dimension for our section view and detail view. So let's clean up our drawing by moving and positioning those dimensions. So you can move those dimensions by using the shift key to the other view. So it looks better. Now those detailing tools really helps us a lot. Another extra credit piece of functionality is the broken out section. So just creating a spline around the lower half a while ago and adjust the distance. So it will update the information. Some more extra credit is to turn off the tangent edges. Okay. Insert the model items on that view. And the last thing that you want to do is to turn on the hidden line so that you can see the edges associated with it. So these are the comfort level of the detailing capability of SOLIDWORKS. Now, what about creating assembly drawings? Using our available template, you can choose your preference. So just choose the miter saw and click multiple views. And SOLIDWORKS can easily show those different detailed views of your drawing. So let's position and align those views. Next, we want to show this isometric view shaded. Alright. Next, show this in exploded view. Now, SOLIDWORKS provide a flexibility for this exploded view. So just change the view orientation. You can see a more clearer view of those parts in an exploded view. How about adding the bill of materials? Simply right click and there you go, the bill of materials. It shows parts including description and part number. How about adding balloons to our exploded view? So just using the auto balloon command and choose the circular balloon orientation in our view. Okay. So that concludes our miter saw demonstration, and at this point, we want to summarize what we have seen during this presentation. Another extra credit piece of functionality for our ultimate view of the miter saw assembly. So from that front view here, you just access the ultimate position view. There is an existing configuration called head down and choose that. So in just a few seconds, you will see that result. Thank you so much for your time for joining this session and hope to see you in our other sessions. Thank you.